go. Here we go. This is the last one. The last one, guys. It's Tuesday. It's review day for your quiz tomorrow. We are going to do 10 problems together. We're going to do them together on this video. You have no Google form to turn in today. All I need you to do is go through this video with me. Pause right before I solve each problem. Try it on your own, just like we would in class. Unpause the video, watch me solve it, see if you got it right. Okay? You get it right, good. If not, move on to the next one. Try that one out. 10 problems, that's all I'm going to ask you today, guys. That's going to be our review to get you ready for this quiz tomorrow. If you guys have any questions, please email me. Make sure you join my office hours. But I'm going to post up the quiz tomorrow. It's going to be the last grade of the school year for you in math. And you have to have it in by, I believe, Friday. We want it in by Friday. Might have some time after that, but I'm not sure. All right, here we go. Let's jump into it. Fractions are first. We've got 4 fraction problems to practice real quick. First one we're going to do here, or all 4 of them are going to be unlike fractions because it was the toughest kind. So let's start with number 1. Go ahead and try it out real quick. Pause the video. See how you did. Number 1, 1/4 minus 3/12. The problem with this is that the denominators are different. And denominators are really the size the fraction pieces are, right? Fourths, if something's cut into fourths, they're pretty big pieces, like a candy bar cut into fourths. I'd take a fourth of a candy bar. But if a candy bar was cut into twelfths, those are tiny pieces, right? So to be able to subtract those pieces or to add them, you need to have the same size pieces. So what you do is you make them the same size pieces, right? Fourths are bigger, so you would need less of them to make twelfths. So what you have to do here is essentially use the least common denominator here and make them the same. So what I like to do is I like to stack my fractions like this. 3/12. And then create 2 equivalent fractions where the denominator is the least common multiple. And the least common multiple between 4 and 12 is 12. If you were to skip count by those 2 numbers, the first number you'd run into both of them is 12. This fraction down here doesn't change because the denominator is already 12. 3/12 is equivalent to 3/12. But 1/4 is going to be equivalent to 12ths in terms of, if we multiply this by 3 to get to 12, we do the same to the numerator. And it turns out that 1/4 is equivalent to 3/12. So really what we're doing is 3/12 minus 3/12. And 3/12 minus 3/12 is 0 for number 1. Well, that was a subtraction problem. I'm willing to bet that some of you added on accident there. Let's hop to number 2. Pause the video, try it out. And you're back, hopefully. 3/8 plus 7/12. You need to find a least common multiple between 8 and 12 so you can combine these pieces, or these fractions, right, which are both less than 1. Again, my favorite way, stack them and rack them. If I were to skip count by 8 and 12, what's the first number I would say? Let's start with 12. 12, 24, 36, 48. Okay, let's try 8s. 8, 16, 24, 24. They'll both go into 24, so that is the least common multiple, which is the least common denominator. Now both fractions need to change on this one. This one's times 2 to get to 24, so we did the same thing to the numerator. And 7/12 and 14/24 are equivalent. Down here we need to multiply this by 3 to get to 24, so we do the same thing to the numerator. And 3/8 and 9/24 are both equivalent. Now, you can add these together. 9/24 and 14/24. 14, 9, 23, 24. So the answer, 23/24. That is in simplest form. Next, number 3. 10 and 2/3 plus 5 6/7. These are mixed numbers. See how you do. Go ahead and try it out. Alright. In order to add mixed numbers, all you have to do is add the whole numbers and add the fractions together. The problem here is that these two fractions have different denominators. Again, same problem we had with the first two problems. So what I'm going to do is I'm actually not going to worry about these whole numbers for a second. I'm just going to take these fractions down here, stack them like I would of the other ones, and let's get these to have common denominators real quick. What is the least common multiple between 7 and 3? Turns out it's 21. So up here, if we multiply by 7, 2/3 is equivalent to 14 over 21. 6/7, we multiply this by 3, is equivalent to 18 over 21. So let's add the two whole numbers together, the 10 and the 5, so we get 15. Now let's add these two fractions together, 14 over 21 plus 18 over 21. 14 plus 18 is 32 over 21. Now that should look odd to you, and it does because it's a improper fraction. So we can take this 32 over 21 and we can fix that. Right? We can take 32 over 21 and fix it. We divide it. Right, let's hop off the side here real quick. Let's just do 32 divided by 21. 21 goes into 32 one time. And that leaves us with 11 left over. So we can just make a mixed number out of this. That's 1 and 11 over 21. Next, since that's what this fraction right here is, I gotta make sure to add this whole thing right here to my 15, right? So it's 15 plus 1 and 11 21st, or 11 over 21. Well, we can add the whole number together. 1 plus the 15 makes 16. And then our fraction, 11 over 21. There we go. The answer is 16 and 11 over 21. And that is in simplest form. A little tough one because there's a lot going on there, but find a common denominator, add them up. Nika thought that was food. I don't get her out of bed. Alright, number 4. The next one we're going to do here is a subtraction problem of mixed numbers. This is probably going to be the toughest type of problem you could do. Okay, so I really want you to try this one, and let's see how you do. 17 and 2/9 minus 12 and 1/3. Okay, here we go. Just like the addition, we just need to subtract the whole numbers and the fractions. But here's the problem. Subtracting 2/9 minus 1/3, the first issue we have is they don't have a common denominator. So let's do that real quick. This one's kind of easy because 9 is going to be their common denominator. We just need to multiply this one up. Okay, so if we do, we can change. If we multiply 3 times 3, we get 9. That's 9ths we need. So we multiply 1 times 3 and we get 3/9. So instead of 12 and 1/3, we're going to use 12 and 3/9 because 1/3 and 3/9 are equivalent to each other. We can just use that instead. And it makes it easier on us because now we have a common denominator. Now we can start to get to work on subtracting these. So if we do 17 minus 12, that's 5. And then we do 2/9 minus 3/9. Can't do 2/9 minus 3/9. Now technically we know we can subtract bigger numbers from smaller numbers to get negative numbers, but it doesn't work in the case of mixed numbers, right? We need to create more 9ths to be able to subtract 3/9. We only have 2/9, but we need to take 3/9 away. Here's the cool thing about mixed numbers. There's still 17 wholes over here, right? So imagine this was a candy bar. You have 2/9 of a candy bar and you have to take 3/9 of a candy bar away. You don't have enough? That's okay because you have 17 more candy bars right here. You can take one of those, break it into pieces, and get more 9ths to be able to subtract. So what we'll do is we'll actually take one of those candy bars out. And if you take a candy bar and you cut it into 9ths, a whole candy bar cut into 9ths gives you 9/9. It gives you a whole another 9/9. And we're going to take that 9/9 from the one we just took from there, and we're going to add it to the 2/9, which gives us an improper fraction. So instead of 17 and 2/9, we now have 16 and 11/9. It's the same thing, same amount, just cut a different way, so now we can subtract. Now we can actually do minus 12 and 3/9. So let's go ahead and do it. 16 minus 12 gives us 4. And 11/9 minus 3/9, 8/9. Dude, are you eating that paper? Look at her, she's eating. I threw it. You're such a dork. Oh, now she's acting like she's not eating it. Okay, whatever. 4 and 8/9. And again, that's the toughest type of problem I can give you guys. I am going to put one on your quiz. So if you're struggling with it, you can practice a couple more. Ask me some questions if you do. Like I said, I still got my office hours going. If you guys want to practice one with me there, I'm totally down for that. Now let's jump into some more of these integers real quick. These are going to go fast. Let's start with number 5. 9 plus -7. You have 9, and I'm telling you to add a -7 to it. Adding a negative number really means to subtract it, right? If I tell you to add a negative to something, it really means to subtract it away. So really what we're looking at here is 9 minus 7. Is that type of concept. So 9 minus 7 is 2. The answer to this one, 2. Number 6, -3 minus 5. -3 is below 0, and if you guys need a number line on these, they can really help you. Please print one off and use it. -3 is below 0. You're already at -3, and I tell you to subtract 5 more. Now you got to think to yourself, is that going to get you into the positives, or is that going to take you further into the negatives? Well, if you're already at -3 and I tell you to subtract 5 more, that takes you further into the negatives. Where do the negatives does it take you? If you're counting backwards, down to -8. Number 7. 20 minus -20. That guy right there, huh? Double negative. 20 minus -20. Really means 20 plus 20, because a double negative is a positive. Number 8. -6 times -6. Negative times a negative. Answer is going to come out positive. 6 times 6 is again, these problems are kind of quick. It's just about kind of remembering your rules. Number 9. -42 divided by 8. Negative divided by a positive. The signs are different, so we know our answer is going to come out negative. 42 divided by 8. 6. Your answer is -6. Number 10. 3 times -10. I know what 3 times 10 is. It's 30. But positive and a negative means your answer is going to come out negative. -30. Guys, that was the review I got for you. I am going to post up a quiz tomorrow over just that stuff right there that I just showed you. Some fraction practice, some integer stuff, which you guys are going to get really in depth with next year. Hopefully this is a great jump start to that. And that's it. See you guys tomorrow.